So I'm given a problem where there are two ships on the surface, A and B, which are trying to direct an aircraft where it should intercept a submarine in 20 minutes. And I'm given the position vector from the origin to A to be 4, 0, 0, because that's the position of A in relation to the origin. And I'm given the position vector from the origin to B to be 0, 5, 0, because that's the position of B in relation to origin. And then I know the vector from A to the submarine and the vector from B to the submarine, but I don't actually know the magnitudes of them. So I need to multiply both those by a scalar to get the position of the sub at time t equals 0. And I know that this vector plus this vector times the scalar that I just mentioned, and this vector plus this vector and a different scalar is going to be equal because they both end up at the same point. So I can set up an equation over here where I say 2a, and I'm letting a be the scalar for this, the a vector, and I'm going to allow b to be the scalar for the b vector. So I can say 2a plus 4, comma 3a, comma negative 1/3 a is equal to 18b, comma 5b minus 6b, comma negative 1b. And where I'm getting these numbers from is the 2a is that vector that needs the scalar, and then the 4 that I'm adding is the position, and I know that I don't need a scalar on that because it's a set quantity with a definite magnitude. So I can solve those for these equations, which allow me to solve for a is equal to 1 and b is equal to 1/3. So I can plug those two numbers back into one of these to get the position of the sub at t equals 0, which I was solving for in the first place using these, because I'm essentially solving for the vector from here to here, which is the position of the sub at t equals 0. So the position of the sub at t equals 0 is 6, 3, negative 1/3, because I just substituted 1 into this equation right here. And then I know the velocity of the sub is the position at t equals 0, which is right here, minus the position vector at t equals negative 4. This gives me the velocity of the sub per minute, which allows me to solve for the position of the submarine at time is equal to 20, because I know the position vector at t equals 0, and I can add that to 20 times the velocity. And that's going to get me with 26, 23, negative 1/3, which is the final position of the sub at t equals 20, which is where the aircraft should have the intercept.